Hello students, in this video we'll learn about different methods of integration. So for that, first we should know what is integration. Integration is an inverse process of differentiation. Integration is an inverse process of differentiation. That means actually integration is used to find a function when its derivative is known. Integration is used to find the function when its derivative is known. For example, integral minus 1 by x square dx. Suppose this is the given function. We know that minus 1 by x square is the derivative of 1 by x. So, integral minus 1 by x square dx, that is actually 1 by x plus c, where c is the constant of integration. We'll take up one more example. Integral 1 by 2 root x dx. Integral 1 by 2 root x dx. We know that 1 by 2 root x is the derivative of root x. So, integral 1 by 2 root x dx, that is actually root x plus c. So, we can conclude that integration is used to find the function when its derivative is known. When its derivative is known. So, how to write the integral function? That is, suppose y is equal to f of x is the given function. If you want to calculate the integral of this, that means integral f of x dx. Suppose the answer is considered to be capital F of x plus c, then this f of x is called integrand. F of x is called integrand, and this is a notation for integration, and here x is the variable. X is the variable of integration, and this c is called the constant of integration. As c varies, the function goes on changing. So we'll get a primitive of the function. That means we'll get a family of curves. So integration means it is also finding the antiderivative of the function, or it is finding the primitive of the function. We have learnt about derivative of the function. So we know many formulas related to derivative. Now, as integration is the inverse process of differentiation, we should know all the formulas related to derivatives. For example, derivative of x to the power n, that is nx to the power n minus 1. But under integration, if we consider integral of x power n dx, answer is x to the power n plus 1 divided by n plus 1 plus c. If we compare derivative and integral values, under derivative, if you want to write derivative of x to the power n, then dy by dx, that is actually nx to the power n minus 1. Here the power reduces by 1. Under integration, if we compare the formula, then integral x power n dx, that is x to the power n plus 1 divided by n plus 1. So power is increased by 1. For example, integral x to the power 3 dx. This is actually increase the power by 1, that is x to the power 4 divided by the same number plus c. Suppose if you have integral x dx, x means x to the power 1 it is. So if we increase the power by 1, this becomes x to the power 2 divided by 2 plus c, where c is the constant of integration. So such type of integrals are called indefinite integrals. So for all the answers of the indefinite integral, you have to attach the constant of integration, that is c. Okay. Now we'll recall all the derivative formulas. Using that, we'll form the integral formula. So this is the first one, integral x power n dx, that is equal to x to the power n plus 1 divided by n plus 1 plus c. Now consider trigonometric functions. Integral sin x dx. We know that sin x is the derivative of minus cos x. So integral sin x dx is minus cos x plus c. Consider integral cos x dx. We know that cos x is the derivative of sin x. Derivative of sin x. So integral cos x dx is sin x plus c. Suppose if we consider integral secant square x dx. We know that secant square is the derivative of tan function. So integral secant square x dx equal to tan x plus c. Similarly, cosecant square x dx. Integral cosecant square x dx. We know that cosecant square is the derivative of minus cot x. So integral cosecant square x dx equal to minus cot x plus c. Suppose if we consider integral secant x tan x dx. We know that secant x tan x is the derivative of secant function. So integral secant x tan x dx gives secant x plus c. Consider integral cosecant x cot x. Cosecant x cot x dx, that is minus cosecant x plus c. Like this, we can consider inverse trigonometric formulas also. For example, integral 1 by root of 1 minus x square dx. We know that 1 by root of 1 minus x square is the derivative of sine inverse x plus c. Or you can also consider minus cos inverse x plus c. Similarly, integral dx by 1 plus x square. We know that 1 by 1 plus x square is the derivative of tan inverse x or minus cot inverse x plus c. And finally, integral dx by x into root of x square minus 1. We know that 1 by x into root of x square minus 1 is the derivative of secant inverse x or minus cosecant inverse x plus c. So these are the different formulas. By comparing with the values of derivative of the function. Like this, we can consider integral e to the power x dx. We know that derivative of e power x is e power x only. So e power x plus c. Suppose if we have 1 by x dx, integral 1 by x dx. We know that 1 by x is the derivative of log x. So it will be log of mod x plus c. Suppose if we have integral a to the power x dx, then answer is a to the power x. Remember, while using integration, we have to divide by that term, that is log a to the base e, but under differentiation, we used to multiply by that term. So integral a to the power x dx, that is equal to a to the power x divided by log a to the base e plus c. So these are few basic formulas related to integration. So in the next video, we'll learn different methods of integration using these formulas also. And we'll calculate the exercise problems also. Thank you.